All right, dilations. When you think of dilation, what do you think of? Your pupils, right? Most people think of what? Gets smaller. Either way, they can go both ways. My husband was actually in the hospital. You know, the week I was out for COVID? Did I tell you my husband was in the hospital that Sunday night to Monday night? He has a pupil that won't dilate like the other one does. And so the muscle like constricts it and therefore causes crazy pressure. And he will go blind if he doesn't put drops in his eye every day to loosen that muscle up to be able to dilate. How fun is that? Oh, he has an appointment today for that. I hope he remembers that. Pause, please. Anyway, so dilation, most people think of pupils. There's plenty of other dilations that can happen just with a figure, and that's what we're going to focus on, is how a figure will dilate. So with dilations, first some terminology that you're going to need to know. It has what's called a center of dilation. Okay, that means the point that you are dilating from. So your center of dilation of your pupil would be the very middle of your pupil, right? That's the point that it's dilating around. We call this C. So when you see a C, that's the point that we're dilating from. It also has a scale factor, and you guys have done scale factor quite a bit. This is what those questions 38 and 39, 34 and 35, the questions from last night's homework that dealt with scale. That's why we threw those in there. We call our scale factor N, okay? Dilations do an interesting thing. They actually preserve angle measure, meaning your angles on your figures that are dilating are going to stay the same, but they don't preserve, what's the other thing? What? Yeah, it's the side length, the distance, okay? So it's not going to preserve distance, meaning this is not a what? Rigid motion, okay? Dilations are not a rigid motion. They will be different sizes. If they're not different sizes, it's not a dilation, okay? Dilation's either going to grow or shrink. Okay, so with this C is your point of dilation, your center of dilation. You could say that's also your C prime. That's not going to move, okay? So C will always be C. So if you're looking at your new figure, C prime is still in that same spot. The center of dilation does not move. And then what you're going to be working with is distances here. So this length right here, CR, so the distance to your original figure, right? We would call that CR. If you multiply that by your scale factor, so N times CR, it's going to equal the CR prime, okay? So if you multiply it by a scale factor, it will equal this setup, which means if we're trying to find our scale factor, if we're trying to find N, if I just divide by CR, right, I get CR prime divided by CR. An easier way of saying that is when we are doing this, it will always be the image. Remember, the image is your new figure, what it became. What's the original figure called? The pre-image. Okay, so your image over your pre-image, that's your scale factor, which we call N. Okay, image over pre-image. I'm going to need you to say that like 15 times today so that you keep it straight, because it always gets flipped around for people. It's really tempting to say your top number is the number you start with and your second number is the number it becomes. It is not that way. It's your image, your new figure length, over the pre-image figure length, okay? Which is what I wrote. Oh, here. Right here, scale factor N is going to be image over pre-image. I wrote it off to the side, sorry. When your dilation is an enlargement, okay? If you stop and think about that, you know what I'm saying, right? It got larger, it's an enlargement. So if your scale factor is an enlargement, if your dilation is an enlargement, then your scale factor is going to be a number greater than 1. Okay, stop and think about that for a second. If something's growing, the scale at which it grew has to be more than 100% of what it was. What whole number represents 100%? 1, right? The number 1 represents 100% of something. So if it's 1.25, now it's 125% of what it was, okay? So that's an enlargement. It got bigger. But if it's a reduction, then your n is going to be between 0 and 1. In other words, it's a fraction of what it used to be. So if I had 100% of something, and now I have 3/4 of that thing, it shrunk down a little bit, right? Something between 0 and 1. So in other words, we're saying this is more than 100%. This is a fraction of what it started as. Does that make sense? Okay. The notation, the rule, if you will, for dilations, shocker, is a capital D, okay? So D for dilation, and then we will say the dilation of some point becomes the scale factor times your x value and the scale factor times your y value. So if you can find your scale factor, or they'll give you your scale factor, you just multiply it by each value. It's really quite simple when you stop and lay it out. Okay, so I have 3 of these where you're going to tell me it's an enlargement or it's a reduction. What is the center of dilation, and what is your scale factor? Okay, so first thing you need to pay attention to is the notation here. This is a B. This is a B prime, right? Then you have a C, and you have a C prime. Is this an enlargement or a reduction? Enlargement. Enlargement. It starts as ABC. It grows to the primes, okay? So this is an enlargement. Anyone know the center of dilation? What point are you dilating around? A. It's your A, right? A didn't change. Remember, our center of dilation is not going to change. So C became C prime. In this case, A is also A prime. Okay, so your center of dilation is the point A. Okay, now here's the part that gets mixed up a lot. We're looking for a scale factor, and the scale factor is the length of the one over the length of the other. Which one goes on top? Pre-image or image? Image. Image on top. So it's going to be image over pre-image. Okay. What is the length of the image of the big triangle? What is?
6.
It's not 6. It's 9, right? The big triangle is this one. Okay. So 3 and 6 put together is 9. Okay. What's the pre-image length? 3. This is your pre-image length. So 9 over 3 is a scale factor of 3. That means that second triangle is 300% of the first one. Okay. Now here's the deal. This is what I need you to really think about when you're doing this, because a lot of times people tell me the right thing here, and then the scale factor they give me doesn't make sense. If this is an enlargement, it has to be more than 100% of what it started as. So would it have made sense to say my scale factor is 1/3? No. So that's how you can kind of check, did I flip them the wrong way? It's got to be 3 times what it started as if it's an enlargement, not 1/3 of the size, okay? Okay, let's just go to the one right below it. We start at EFGH. We go to the primes. So is this a reduction or an enlargement? Reduction. A reduction. It started at the big one. It shrunk down to the small one. So that's a reduction. What's your center of dilation? C. It's that point in the middle. Okay. So C is your center. Now your scale factor. 4. You have image over pre-image, right? So 2 over 8 is a scale factor of 1/4, which makes sense for a reduction. It's 1/4 the size of what it started as. Okay? Questions on that? Okay, you try this one. Reduction or enlargement, what's the center and what is the scale factor? Work it out on your own. I'll check in with you in a minute. Do any of you have Miss Shiraki in elementary school?
Yeah.
She has my son right now. It's his birthday. She just sent me pictures. She's so sweet. Okay, reduction or enlargement? Enlargement, right? You go from the A, B, C, D to the prime, so it got bigger. What's your center of dilation? Point A. Point A did not move, right? So that's your center. And then what's your scale factor? 2. It's got to be the image, right? This is your image over your pre-image. Okay, so it's 4/2, or 2, okay? It doubled in size, right? It got bigger, it doubled in size.
Wait, so will the center always be A?
No, it will always be the point that doesn't change. So sometimes that's a point like in the middle of the figure that didn't change. Sometimes it's a point on the figure where A is A prime.
That's why.
Yeah, they just don't label it both ways.
Okay.
But it is technically your A prime. Yeah. Okay, these ones are really simple. Remember what I said about the notation. It's the dilation of whatever scale factor of xy becomes nx and ny, right? So all you're doing is you're taking this number and you're multiplying it by both of those. So your new x value is what? 2. 2 times 1. And your new y value? -10. Okay. Letter B then. 0, 3, right? Half of 0 is 0. Half of 6 is 3. So you're just multiplying that 1/2 by 0, putting it here. 1/2 by 6, putting it here. Okay. Last one? 0, 0. Multiply 0 by 10, you still get 0. Any questions on those? Okay. Last thing. This says, what are the coordinates of the vertices of a dilation of 2 of triangle LMN? And graph it. Okay. I think on these ones, it's easiest. You can think of it as a relationship from the point of dilation. When it's on a coordinate plane, our point of dilation is always going to be 0, 0. Okay, every time. Yeah, Whitney.
Would you basically just take like each of the points and then multiply them by 2?
That's what I would do. You don't have to do it that way because there is a relationship that I'll show you once we find all of our points, but I would do it that way. So I would say L, M, and N are what points? So L is -3, -2. M is at 1, -2. And N is at 2, 3. Okay, so now we can find L prime, M prime, and N prime. This being the key, this little 2 right there, right? If we're doing a dilation of 2, what are we doing with that number? Multiplying by 2. So -3 times 2 is -6. -2 times 2 is -4. So that'll be your L prime. Then our M, 1 times 2 is going to be 2. -2 times 2 is -4. And then N, 2 times 2 is 4. And 3 times 2 is 6. Now watch what happens. If you plot those points, -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, there's L prime. M prime is at 2, -4. Okay, and then n prime is at 4, 6. Yikes, 1, 2, 3, 4, 5, 6. Okay, and then you draw that triangle in. Pardon my not straight lines. Do you see a relationship? Do you see something else you could have done?
Like, so from 0 to the point, like for point M, it has 2 boxes vertical.
Mm-hmm.
So if you just go diagonal with those 2 boxes, you'll have that.
Right. If you kind of treat it like a slope a little bit, I went up 3 over 2. So if I do that again, up 3 over 2, that gets me my new point, right? Same thing down here. If I go down 2 to the right 1, down 2 to the right 1, that gets me my next point there. This one down 2 to the left 3, so down 2 to the left 3, that will get me my new point there. So I think it's safer to do it this way where you do the multiplication, but that will be the relationship every time because you're always going from 0, 0, okay? Questions on that? Submit your note.